Interesting.
Okay, well, we can just start here, go through as many as you'd like.
Okay.
Uh, there's a lot of multiple choice here, so we can skip some of those if you want. Um, actually, well, I mean everything is multiple choice after this one, but I mean that doesn't help you for understanding. So you can decide what you want to do on this. So if you're seeing my screen, you see question 1 here. They want you to list the elements of this set, and they're saying it's the numbers that are between 3 and 11, but they don't include 3 and 11. So that would be 4, 5, 6, 7, 8, 9, 10, and that's all it's asking for the first one.
Okay.
Are you able to pull up the assignment on your side to
Yeah.
see what I'm? Okay. Might be good for you to just say, Matthew, can you only do this one, or or maybe we go to 7.2, where there's some
Okay.
more numerical
Um,
ones.
why? Just because like it will be easy for me just to like.
Well, you get 20 submissions, so you can
Okay.
and sometimes it's easier to learn from, oh, that's why it's the answer, and then we can come back
Right.
to those.
Okay. Let me check the other sec. Have you checked 7.3?
I have not, just 7.1. So
7.3 looks better.
okay.
It's
Do you want me to go in order with 7.2 first?
Well, it's 7. Oh wait, what am I on right now? So 7.1. So, oh, I don't know why it's out of order. Let me look at 7.2.
This is
Sure,
worth
yeah, we can
worth
look at
doing.
7.2.
All right, so we're in 7.2 here. Number 1, they give you the sets here. They tell you set 1 contains these 4 names. There's 4 total here. And then set B contains those 5 names, and then set C contains those 2 names. This N of A means the number of elements that are in A. I've already given that to you. That's 4.
So,
Number B is 5. Number in C is 2. And they just want you to add those first 2. So that's 9. That's a nice starter question here. The next one is a bit harder because it's got more involved in it. So we'll talk about that one. Okay, so question 2 here. It says find this thing right here, the number of A intersect B intersect C. So we got B intersect C. That's the first thing. So we're looking for the overlap between B and C. So what I like to do is actually just like check mark the ones that are the same. Okay, so like so Hans doesn't appear in both, but Franz does, or Franz, whatever. So the B intersect C is just Franz. Now how many of these names are also here? Well, that's also Franz. So you first start with these 2, and then you take the out and combine those. But the only ones that overlap is that Franz. The answer is 1 there. Okay, 3, we're going to draw a picture. So you've seen these before in other classes. We're drawing a Venn diagram here. This is A, this is B, and this one in the middle here is them both, the and. The A intersect B. A intersect B means and, it means both, and so on. So the number that are in both is 9. And then B is 8, because 9 plus 8 has to equal that's 17 there. That's the 9 plus 8. And then A includes this 60, this 9. So whatever goes here plus 9 has to equal the 61. So that's why it's 52. 52 plus 9 is 61. So A union B means or means like one or the other or both, or is all 3 of these. So the number in A or B is 52 plus 9 plus 8. Ends up being 69 total there. Next one's got a bit more challenge because it's got a lot more names. Some people like this part of the course because it's not as numerical. Okay, we're looking for inside here, we're looking for A intersect B, but then this symbol right here means not. So if we figure out how many are in A intersect B, the not means basically the total minus the ones that are in A intersect B. So we got to figure out how many are in both. So it's just kind of name by name, like is South End in both? It is. Yeah, South End is in both A and B.
Mhm.
And then Liverpool is not. Maroka is not. Maroka Swallows is not. Royal Tigers is not. Okay, so there's only one that's in both. So the number that's in A intersect B is 1. Okay, and how many are in the total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like there's 10 total in the set. So the number that are not in A intersect B is 10 minus 1.
Okay.
Which is 9. So you got to get really careful with the notation there to understand.
So the prime means what's not?
It means complement, but not is a good way of referring to it.
Okay.
All right, so the way to do these is okay. So normally they give you this three Venn diagram, and you actually would start in the middle. The middle is like where they all overlap, but we don't have that information. We just know that A is 15. So A is this circle here. It's got 2 missing ones. That's no good for us because we don't know 2 of them. But B is 10. So 1 plus 0 plus this empty space, which I'll call for the moment X, plus 5, that has to equal 10 because all of these have to add up to this number of B there. So you can see that X is 4. Okay. Now we can go back and do A because I'll call that Y. Y plus 1 plus X, which is really 4, plus 10 equals 15.
Wait, why is it 4?
From the previous line here. So let me back up here, I guess. Just get rid of some of this stuff. Oops. Okay. B includes everything in this shaded region here.
Okay.
Okay, so that's where you get the 1, the 0, the X, and the 5, and they have to all add up to 10 because it says so there.
Oh, okay.
So X has to equal 4 because that's the only way that works. A is all of these. And that's why I put a Y there. So it was like Y plus 1 plus X, which is really 4, plus 10 has to equal 15.
Okay.
So if you solve for Y ends up equaling 0.
Okay.
Okay, so now for the next one for C has got everything in here. So C, which is 31, this is for C, is 10 plus 4 plus 5 plus, I'll just put a Z there, plus C. So 31 equals 19 plus Z, so Z ends up equaling 12. Now the whole thing they tell you is 39. So all the numbers that are given here have to add up to 39. So let me just redraw it. Maybe that'll be easier here to see. So we got this one, and this one. So we got 0, 1, 10, 4, 0, 5, 12, and then this last number here, which we don't have, I'll call W. All of these have to add up to 39. So 39 is 0 plus 1 plus 0 plus 10 plus 4 plus 5 plus 12 plus W has to equal the 39. So it's 11, 15, 20, 32. Looks like W equals 7.
What is like the point of this? Like, is there gonna be like you know what I mean? Like, does it set you up for something else?
They might ask you some probability questions. You're in probability and statistics, so I don't think you get that much more depth into these.
Okay.
It's not really connected to the calculus stuff you did either. It's just
Right.
new. Like your class covers a variety of topics in mathematics, but none of them in much detail. Okay. We want the set of housing starts in the Midwest in 2014. So 2014 is this row here. And we want the ones that are in the Midwest, that's here. So the number we want is 110,000 because that's where they intersect. So which of these shows the intersect? Well, it has to be this upside down U.
The last one.
So it's the last one, yeah. The cardinality is that's what we've been. That's this N of is what the cardinality means. I didn't mention that earlier because I didn't remember.
Okay.
All right, so see if you can do this one, please.
So is it 330?
So it's in 2013, so that's this row, but it excludes the ones in the south. So it's not that one, but it must be the other ones.
Oh, okay. So B and then I was gonna say it would be the like not S, but it's not there.
Yeah, they used not T to indicate that. So I guess we'll go with that one. So I think it's the adding of these. It's the 290,000. Let me try that and see if that works out. Okay, that's good. Maybe another question on this. All right. Do you want us to keep going through this? The problems do get more difficult, or do you want us to move to a new section?
We can. How about we just do like one more difficult one and then move to a new section?
Okay. All right. This is question 12. This is somewhat the answer to what you were asking me earlier. It's like this is the extension of the questions where you don't just give a count. You do a probability.
Okay.
So the what percentage of established authors are successful? So here's the established authors. How many are successful? Well, it's 20 out of 78.
26%.
Yeah, so let's say 26%. 2 decimal places though, sorry.
Oh, so then it's 25.64.
We're doing 20 out of 78. Yeah, 25.64. Yeah. Okay, what percentage of successful authors are established? So that's now this row. And that's the 20, that's the ones we want out of the 24.
20 out of 24 are 83.34 or 83.33.
Yes, 80. What did you say? 84.33?
Mm-hmm.
83.33. Yeah. Okay. Let me just enter these in before we move on. Okay, so those are submitted. Great. Okay. We'll move on to 7.3, I guess. Let's see what that one has in it. Okay. Not that many questions. All right, the surgical procedure requires choosing among 4 alternative methodologies. The first can result in 6 possible outcomes. The second can result in 3 possible outcomes. The remaining methodologies can each result in 4 possible outcomes. Those are the total number of outcomes. So there's 4 buckets here, and each bucket has a number of outcomes. There's 6 for that first one, 3 for that second, and then 4 and 4. The total number of outcomes you get from multiplying those together.
288.
Can you give me that number one more time?
I think 288.
288. That sounds pretty reasonable. So it gets quite large pretty quickly. Nope, didn't like that. 6 times 3 times 4 times 4. 288 is what I got as well. I wonder if this 4 methodologies, that's the first bucket. Maybe there's one more here. Let me see if that's the case here. So that's 1,152. Let me try that. Did not like that. Let me check the other one here and see if I can figure out how they do it. 7, 3, 4. Oh, they just add up the numbers.
Oh.
So that's weird. But you probably would want to remember that if you got this on the test, because it's just the addition of these numbers. I don't have more to say. I guess they're using outcome as, yeah. Person who wrote this question, was probably very clear to them. Not so much to me. So for a given decision algorithm, how many outcomes are possible? Like it looks like there are, like you choose between 1 and 2, but there's 4 outcomes here, and then there's 9 outcomes there. So I would go with adding them all up again. 4, 7, 12, 13. Didn't like that either. This is I'm going to show the answer so I can see if I can figure out. So 25 outcomes, 6. So there's 5. I'm looking at the solution. Let me snip that and maybe you'll see it, because I don't see any explanation here for this. That's reasonable. So here's the snip that in. Okay, so this one, they give you the answers 25. Yeah, I don't know how they get there. Doesn't, I mean, it's not adding them up. It's not, it's not 1 plus 5 plus 4 plus 5 plus 1.
That's weird.
It's like, well, okay, maybe it's 4 times 5 times 1. That's this one. That's 20. And then 1 times 5 gives you 5, and then you
Yeah,
add these together.
yeah.
So for yours, that would be 1 times 3, that's 3, plus 3 times 5 times 1, that's 15. So that gives you 18 outcomes. Definitely would have to have had seen that to have any idea that's what it wanted you to do. That is correct. Okay, how many different 5-letter sequences can be formed from the letters 3 A's, B, and a C? So the way I look at this, I hope this is right, is in the first position, you have 5 possible letters that you can choose. In the second position, you have 4, third position 3, and so on, 2, and then 1. This is referred to as 5 factorial.
Mm-hmm.
Um, so I'll try that. Hopefully that's right. It is not right. Oh my gosh. All right. I'm gonna snip this in. So the problem with the first way of doing this is that, like, you can put AAA and then AAA, and they're the same. So this is I guess, their way of working around this. 1, 2, 3, 4, 5, 6, 7. So one way they do this is you take the number of letters and you write 7. There's 1, 2, 3, 4, 5, 6, 7 letters, 7 factorial. And for each individual one, like there's 5 A's, you say 5 factorial, 1 B, 1 factorial, and then 1 C, 1 factorial. This is called the monomial property or distribution. So you take the number, and this becomes 7 times 6, which is 42. That does impact here. We have 5 letters, so that's your 5 factorial. But there's 3 A's, so that's 3 factorial. And then there's 1 B, so that's 1 factorial over 1 factorial. This ends up being 5 times 4, which is 20. So the shortcut here is whatever this is, it's 5. If it's number 5 times, it's 5 minus 1, or 5 times 4 to get your 20 on that.
Okay.
Okay, starting with question 4, this seems to be more of where I would have thought we would have started this this type of lesson, with these bucket problems, where you choose like how many can be in that position. So it says an ice cream shop claimed to have nearly 931 different ice cream flavors. So the first thing you do when you go there is you choose a flavor. Yeah, your flavor is 931, and you could have it in a cup, cone, cup, or sundae. So that's 3 of those. I don't know what you would, maybe could just say have. And you could choose from a dozen different toppings. So that's toppings here. That's 12. Okay, so you're just multiplying these together. 931 times 3 times 12. That's what we're doing in the first few. That's 33,516. This will be
What
the
do they have
first
so
one.
many flavors? It's weird.
Okay, that does work.
Okay.
So we're moving in the right direction here. It looks like your instructor repeats some of the questions, which is probably good for us to give us a second shot at seeing these. Number 5, though, is a different, it's a new question for us. All right, Professor Ogre must choose between an extra writing assignment and an extra reading assignment for the upcoming spring break. For the writing assignment, there are 2 essay topics from and 3 different mandatory lengths. The reading topic would consist of 1 scholarly book and 1 volume of essays. There are 2 biographies and 6 bios. Okay. This again, it's kind of weird. To me, this is like the alternative 1, alternative 2 thing that we're doing. So alternative 1 in this case is writing and then reading. Like you're choosing between this. We're going to add up whatever it is. For the writing assignment, there are 2 essay topics and 3 different lengths. So to me, there's like 6 possible outcomes there. 2 times 3, like you multiply those together. Plus the reading one, it says that it's a biography and a volume of essays. So there's 2 of those and 6 of those. So that 2 comes there and 6 comes there. There are 2 essay topics that comes there. 3 different lengths comes there. So to me, that's 12. That's 18 possible choices. Okay, that does work. That does work here. Okay, so let me have you try number 11, maybe 12, and then we should move on to another assignment after this, because you may want to try some of these on your own. But 11 is kind of related to what we just did. So this is 3 outcomes on the left, 1 times 3
Yeah.
plus
Plus
4.
20.
Yeah, so this is 23 total. For that one. And then I'll snip in question. It didn't like that. Oh my gosh. That doesn't make any sense. Show answer. 5. This doesn't make any sense. The answer to this one, let me snip the practice one for this one, is 55. 55. Now, how did they get that? So one way is they got 5 here and 11 here. That's 5 times. Oh, okay. So this is different. I see now. Instead of it saying alternative 1, alternative 2, it's a step 1, step 2. And you're gonna have to pay really close attention whether it's a step or like we were doing in this one up here. It's alternative comes before the step. So it's a simple distinction, but it's easy to get it wrong. So here it's
4 times.
yeah, it's 4 times 10, which is 40. Man, what a simple distinction, but big difference here. Okay, let me move on to the next section. There's a lot of problems here, but they're not very long, most of them. Like if you scheduled one more lesson, we could get through all of these, but I'm sure. Okay. 1 and 2 are are just calculator ones that you're gonna end up doing as part of this. So we'll just do a reminder on this. So I'll get down, snip this in. Okay. All right. So it says, how many ordered lists are there of 3 items chosen from 6? So this is 6, choose 3. So your calculator has that C button in there. You probably remember. You have to put this first number in before you go search for the C. It's probably under math, PRB, somewhere in there. And I get 20. It would be good for you to calculate this
Yeah.
just as a practice.
So math. Then what?
I think it's under PRB, math PRB. Not sure though. I can look this up as well.
And is it NCR?
Yes.
Yeah, I got 20.
Okay, great. It did not like that. It's probably NPR. Ordered lists means that order matters. Order matters. That's NPR.
120?
Yeah, there's a lot more when we do it that way. Okay. Okay. All right, let's go to number 6 here. Bag contains 3 red marbles, 3 green ones, 1 lavender one, 3 yellows, and 6 orange marbles. How many sets of 4 marbles include all the red ones? Okay, so you're choosing 4. Okay, you're choosing 4. How many total do we have? We have 3, 3, 1, 3, and 6. So that's 16. 16, choose 4. Okay, that's how many possible ones, but that's not the one that's not what we care about here. That's your sort of your total. We have to get all the red ones. So we have to 3 choose 3 times. There's 13 that are left over, and we're going to choose one of them. Okay, so like for example, this is like red, 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 and then green. Red, 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 the other green. Red, 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 the other green. Red, 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 the lavender. So there's a bunch of these, and that's what accounts for all of these. So you have to do this calculation do this in your calculator. This 3 choose 3 is the one that gives us all the red, and this is the one that gives you the other ones.
What, 6 times 13?
3 choose 3 should be 1.
So am I doing NCR
And
instead?
NCR, NCR for this.
Okay, so yeah, 1.
This should be 1 times 13, which is.
And then is the second one still NCR?
Yes, and you do them separately. I would just get the numbers rather than try to enter them together.
Yeah, 13.
Okay, so then let's go to 7 here. Oh wow, this is the end of this section. Okay, we'll go back and we'll have lots of time to go back and keep doing these. Okay, marble bag contains 2 red marbles, 3 greens, 1 lavender, 5 yellows, and 6 orange marbles. So we want to grab 4, but we want to get 1 of each color. So to get the red, we're choosing 1 red. We're choosing 1 red. How many are we choosing from? Well, there's 2, choose 1. That's your red. Okay. Then we want to grab a green one. So there's 3 green ones and you're choosing 1 of them. We're not doing the lavender. It says other than lavender. 5 yellows, 5, choose 1. That's your yellow. and 6 choose 1 for the orange.
And then how do you know that we're doing NCR and not NPR?
Most of the time you're using NCR. We'll go back through this one. We'll talk about when to use PR. PR is when order matters.
Got it. Okay. I'm just getting the numbers for them.
That's right. It should be 2 times 3 times 5 times 6.
Okay. 180.
180. Yeah, great. Okay, so let's go. Okay, so we got some time left. Let's this one for sure we can finish up without issues. So number 4. It says how many sequences are possible that use the letters once. Use each letter once. So there's no overlap here. Okay, like you just pick a letter and start out. So there's 4 that start out. There's 3 there. There's 2 there, and then there's 1 here. So this is because you're using them each once. That means you have to consume them all. So the next time around, you have 1 left to consume, 1 left to consume, and so on for this one.
So you're just multiplying them?
Just multiplying them, yeah.
24.
24, yes. Okay. Number 5 is slightly different. Maybe. These read are so weird. I really like to make these very clear with the wording when I write them. This one says, how many 5-letter sequences are possible that use the letters DRD, RK? And the problem is now there's overlap. So if you have like the sequence DRD, that's the same as DRD.
Okay.
And what I mean is like if I chose that one to be there and that one to be there, well, now this one is here and this one is here, but they're still the same. And so are those what's not very clear is like, are those different? And I'm not sure. So let me look at another question here to see if I can get some. It's not available for this one. Lovely. So this is like 5 factorial over how many D's are there? There's 2 D's, 2 factorial. How many R's are there? There's 2 factorial. Let's try that. So that's 120 over 2 over 2. So it looks like there's 30 maybe. Try that out and see if that works here. It does work. Okay. So that 5 comes from there being 5 total. And then the 2 is because there's 2 D's and there's 2 R's, but there's only 1 K. Doing it that way. All right, so there's 2 questions left. They're just calculator, find permutations, find combinations. So let's see, let's go back. Any preference? We said we're gonna skip 7.1. Do you remember 7.2 versus 7.3? Which one we should go back to? Spend some more time.
I think it's 7.2.
Okay, 7.2. I'm just going to start back in order here and start with number 8. So this is finding cardinality. This is finding the number of like things that match up. So this one says the set of housing that starts in 2013 in the West and the South. So that's this one and this one. So we know the number. The number is 460. Now we got to figure out which one it is. It's a B intersect. It's a B intersect because we want both. Both here. Both have to be true. So it's west or south. West or south is good because If it was and south, there are none that are in both the west and the south. So that's why that one is out. It must be letter C there.
Okay.
Just entering the answers. 460,000. Great. Okay. Okay, so the next question here, I'm going to have you try. It's a Venn diagram question. I'll start by drawing the Venn diagram and seeing if that helps you. So the Venn diagram here is we got A, we got B, and then this one in here is the A and B, and the A or B is all three of them.
Okay.
So give this a try. You're going to want to fill in this middle number first, and then the other two. I'll be right back. All right. So for example, the A intersect B number is 1.
Yeah, B is
And
one.
then this all over here has to be 44. So it's what number plus 1 gets you to 44? Well, that's 43. B is 18 because 18 plus 1 gives you 19. So now the A or B is the addition of these three numbers, 43 plus 1 plus 18, which is 62, looks like. All right, so we got number 10 here, another Venn diagram question. This one's a little bit more difficult because they're not giving you it's kind of working backwards. They do tell you that the intersection of the two is 46. And they tell you that A is 106. So this here over here has to add up to 106. That makes that 60. 60 plus 46 gives you the 106 there. We're trying to find B, but we don't have enough information. But we know that A or B, which is the 60 plus 46 plus this unknown number here, I'll call that X, has to equal 143. So we just solve that for X. X ends up equaling 37, looks like. But that is not the value for B. Number of B here is all of these added together. It's the 46 plus the 37. So you just got to get comfortable filling these in.
Okay.
And I think you can do that pretty quickly here. So it looks like it's 83. So let me try that out there. Great. All right, we've got number 11. 11 is a kind of a repeat of one we've already done, but it's good to do it again. All right, so a lot of information here, but they want you to find A or B, and then the not of that. So A or B means it could be in both, and we're just trying to count them up. So there's Southend, okay, so that's 1. Liverpool, that's 2. That's 3. That's 4. That's 5. There, and then we just see like, well, like, is Barnsley new? Yeah, it's new. So that's 6. Is Manchester United new? Yeah, so that's 7. Is Southend new? No. So just 7. There's 7 total, and A or B, that's 7. So the number of A or B complement is the total, which is S. It's the number in S, which I think was 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? I thought it was 10 last time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So it's 9 minus the 7 because there's the number of S is 9. That's where that comes from. So this is 2 total. Did not like that. Did I not count these right? So Southend, Liverpool. Oh, there's only, sorry, there's 3, 4 there that double counted. So that's 5, that's 6. That changes that number to being 3. All right, 13. 13. Okay, in a study of children, a total of 1,548 were examined. 1,022 had rickets, 244 urban children in the study, 92 had rickets. How many children living in non-urban areas had rickets? Urban. Okay, so what I think is, and this is really unclear, but I think that the Venn diagram here is this is well, maybe not. I don't know. This is weird. So it's like they start with children and then rickets and then not. So they had 1,022 and then the not would be the 1,548 minus 1,022. Of the 244 urban children in the study, 92 had rickets. So it's like urban. If you're urban, there's 244, and there's those that are not urban. That's 1,022 minus 244. And then of those that were urban, 92 had rickets. That's weird. How many children living in non-urban areas had rickets? I'm missing something. I'm sorry. This is not correct at all. Not a good one for us to finish on. Let me see if I can find something quick here to help. Yeah, not finding anything super clean here.
I can see if my teacher goes over one of these.
This would definitely be a good one to ask because it is super unclear. And then 14 is very straightforward. So, okay, I'm going to stop here, and I'll send out the notes and the screen recording here shortly. Thanks again for scheduling, and I'll see you next time.
Thank you.
Okay, bye now.